Welcome to Physics World Online College, where we simplify physics for you to understand and also to pass your exam. Please click on the subscribe button and share this class video with your friends in the various social media platforms. In our class of today, we shall look at frictional force or friction. We know the definition of friction. We know the two types of frictional force. We know the laws governing solid friction and obtain a formula for determining the frictional force. Likewise, the coefficient of friction. Now we say, if we have two bodies, body A, body B, and these two bodies are put in contact, and then we try to move one of the bodies over the other, frictional force will exist between the two bodies. So we define friction as the force which acts at the separation of two surfaces in contact, of two bodies in contact, and opposes the motion of one over the other. Or we can say friction is the force which opposes the relative motion between two surfaces in contact. We say friction is a force which acts at the surface of separation of two bodies in contact and opposes the motion of one over the other. Or we can define friction as a force which opposes the relative motion of two surfaces, or you say two bodies in contact. Now, you discover that there are some certain points that must be in your definition for it to be acceptable. One, we have two bodies. Two, the two bodies are in contact. Three, there is relative motion between the two bodies. One tries to move over the other. For that, friction opposes the motion. Now, we say we have two types of friction, namely static or limiting friction and dynamic or kinetic or sliding friction. Let's take that. Two types of friction. Number one is static or limiting friction, and number two is dynamic or kinetic or sliding friction. Now, static or limiting friction is the maximum force required for a body to start moving. It is the maximum force which must be applied for a body to just start to move. whereas dynamic or kinetic friction is the maximum force which must be overcome for the body to move with uniform speed or velocity. Let's take that. Static or limiting friction is the maximum force which must be overcome before the body just starts to move. While dynamic or kinetic friction is the maximum force which must be overcome for the body to move with uniform or constant speed. Now, when we reach in details the calculation, I will explain more about this static and limiting friction. The calculation will help us to separate the two of them even further. Now, let's talk about the laws of solid friction. Now, why did we say solid friction? Does it mean there are liquid friction? Yes. Liquid friction is called viscosity. So you will study that in a future topic later. Now, what are the laws? If we have two bodies in contact, like I explained, and one tries to move over the other, I say frictional force will what exists. And one thing that the frictional force will try to do is to oppose the motion of the two surfaces in contact. So that is one of the laws. Friction opposes the motion of two bodies in contact. Now, another place where this first point is noted is in the calculation. What does that mean? Friction always acts opposite to the force applied, which means if you have a body and you have the applied force pulling the body this way towards the east, then friction will oppose that applied force acting towards the west. So it always opposes the force applied. Take note. Another law of friction is that friction depends on the nature of the surfaces in contact. For example, e.g., the surface may be wet, it may be rough, it may be polished, it may be smooth. Now, each of these type of surface gives you different friction. In fact, in surfaces that are very rough, the friction is always high. But in surfaces that are polished and smooth, the friction is less. So friction depends on the nature of the surface. Number 3, we say that friction is independent of the surface area in contact. What does that mean? Now, why friction depends on the nature of the surface? Is the surface wet? Is it smooth? Is it dry? It does not depend on the area. How may I explain that? Let me look at this. We'll have this material. This face has a different area, bigger than this part of this body. Now, if I use this area, this part of the body, and place it in contact with this, and I try to move it over this body, the friction I will get using this area will be the same when I use this smaller area. So long as the nature of the surface here and the surface here are the same, I will get the same friction. But if the nature of the surfaces are not the same, then I will not get the same friction. So we say friction is independent of the surface area in contact. Good. Number 4, friction is independent of the relative velocity or relative speed of the bodies in contact. What does that mean? Friction does not depend on the relative speed of the bodies in contact. What does that mean? I say it means if I decide to keep this body stationary and move this one over it, the friction I will get will be the same thing if I keep this body stationary and I move this over it. So it does not depend on which of the object is moving. No, it does not depend on the relative speed. Number 5, friction depends on the normal force. Depends on the normal force or normal reaction. Normal force or normal reaction or weight of the body. Weight of the moving body. Now, this point will lead us to the calculation, that formula that we have. Another way I will put this fifth law is to say that frictional force is directly proportional to the normal reaction. I'll say it this way. That is, friction is directly proportional to the normal reaction. So putting that into mathematics, we will have this, that friction is directly proportional to normal reaction. So I've used F subscript small arrow as frictional force. This is direct proportional sign. Arrow is a normal reaction or the normal force, which will be equal to the weight of the object if it is placed on a horizontal plane. So if I remove the proportional sign, I will introduce a constant which we will call mu. So we say that frictional force is equal to mu r. This is capital R, standing for the normal reaction. or normal force. So this is one equation which is F1, which is helpful. We say, note that if we have the bodies on a plane or horizontal surface, then the normal reaction, it will be equal to the weight of the body, which is given as the mass of the body multiplying by the what? Acceleration due to gravity. So this is true if the bodies are on a horizontal plane or surface. So with this, we can get the calculation right for the example that is given to us. Please take note that the F subscript arrow means frictional force, while mu stands for coefficient of friction. This means frictional force, and this means coefficient of static friction or coefficient of frictional force, coefficient of friction, while the capital arrow is the what? Normal reaction or normal force, which I said also represent the weight of the body. Good. So once again, if the formula is known and I'm given the coefficient of friction and normal reaction, I can get the frictional force. And likewise, if the frictional force and the normal reaction is known and I'm asked to look for the coefficient of friction, I can obtain it by making it the surrogate of formula, which means if you make the coefficient of friction the surrogate of formula, you will have that frictional coefficient of friction is the frictional force divided by the what? The normal reaction. So I put that as equation 3. I hope you get the point. Now, frictional force is a force. In fact, it's an example of a contact force. So its unit is what? Is Newton. Reaction is also a force. It's also a contact force. Then its unit is what? Is Newton, which means the coefficient of friction, if frictional force is Newton and normal reaction is also Newton, the Newton will cancel this Newton, leaving us with no unit. So coefficient of friction has no unit. Coefficient of friction, mu, has no SI unit. So we say it is dimensionless, no SI unit. So take note of that. So you will see in questions where it is given, no unit is attached to it. If you put a unit to it, then you are said to be wrong. So let's take this calculation and then you will do the classwork that I have given to you. So we have that a mass of 2 kg is placed on a horizontal surface. Solution. We have a body. Let me sketch now. Placed on a horizontal surface. We are given the mass of the body as 2 kilogram. Then the weight of the body will act downwards. And I said weight is mass times what? Acceleration due to gravity. Now this weight is opposed, equal but opposite by the what? Normal reaction, arrow. So arrow is also equal to the weight and it's also equal to what? Mg, which means 2 times 10 giving us what? 20 Newton. So the reaction is what? Equal to the weight. Take note of this question. They gave us the what? The weight of the body. So if they give you the weight of the body, it means you have been given the reaction. You will not start asking, they didn't give us gravity or the mass, because the reaction and the weight are equal. Now, if you have the force applied this way, this FA means force applied. As the force you use to pull the body, then friction has to oppose that applied force. Like I said, because it opposes the motion of the two bodies. So this is the frictional force. F subscript arrow means what? Frictional force. Now, I would say something here. At static friction, that's the type of friction. At static or limiting friction, where the object just starts to move, the force applied is always equal to the frictional force. Take note of that. I repeat, at the point of static friction, because that's what they say you look for, the coefficient of static, find the frictional force. We are given the coefficient of static friction. At the point of static or limiting friction, the force applied is equal to the frictional force. Good. So we say that we have calculated the weight, which is equal to the reaction as 20 Newton. We are also given the coefficient of friction as what? 0.4 without unit. I say it has no unit. And they want us to find the frictional force. So which of the equation will be applicable? We use that equation 1. So we say from equation 1, frictional force is coefficient of friction times what? The normal reaction. Remember, I've determined the normal reaction here. So which means frictional force is 0.4 times normal reaction, which is what? 20. If you multiply that out, you will get what? 8 Newton. This 8 Newton is also equal to the what? Force applied. So the force applied here is what? 8 Newton. Why? Because it's at static or limiting friction. In our next class, I will take on a question that involves dynamic friction so that you know how we will now interpret it. Okay? Please do the classwork and submit it. I will reply you accordingly. Bye for now.